Greetings, ladies and gentlemen. Welcome to video 2 on solving equations with variables on both sides. And let's do a quick recall or a quick recollection of the first video where the essential question said, hey, is it possible to have an equation with no solution? Is it possible to have an equation with infinitely many solutions? Well, the answer to that question is yes. Ladies and gentlemen, put everything down, pens, pencils, everything down. Please make sure you listen first and then pause when I'm done so that you can write it all down and move on to the next example. So we're telling you right now that the answer to this equation is no solution. That's not the point. When you're doing your practice, you're not going to know that ahead of time. You're just going to be given an equation. But there are some things that you can recognize, some stuff that will point out, hey, this, when I get done solving this, there's no solution to this equation. So you're going to recognize what those things are. So have your stuff down. Here we go. Right now it says solve 3x minus 5 equals 7 plus 3x. Okay, we know what to do. We've been doing this. We're going to combine like terms. We're going to combine this 3x by moving it to the left side. So opposite sides means I need to do inverse operations. 3x minus 3x, that's 0x. I'm left with no x's. There's none left. All I'm left with is this right here, negative 5 equals 7. Well, hello. I don't have to be a mathematician to know that negative 5 does not equal 7. This is false. So no solution. No solution to this equation. Recognize that you have the same exact variable on opposite sides. Opposite sides of the equation has the same exact variable. Ladies and gentlemen, pause the video, get it written. Join me in example number 7. Welcome to example 7, where we're going to solve 6 times the quantity of 5 minus 2x is equal to negative 4 times the quantity 3x plus 1. We have to simplify by eliminating the parentheses this time, so let's just get started. 6 times 5 is 30, and 6 times a negative 2x is a negative 12x. Negative 4 times 3x is a negative 12x, and negative 4 times 1 is negative 4. And when I go to simplify this time, I recognize by moving this variable to the other side using the inverse operations by adding 12x to a negative 12x, I get 0, leaving me with 30 equals negative 4. No, it's not. That's false. No solution. Ladies and gentlemen, pause the video, write it all down, and join me for example 8. Welcome to example 8, where we are now going to solve equations with infinitely many solutions. And yes, you won't know it when you're doing your practice, but you'll be able to recognize it as you are solving this equation. Again, solving it is done the same exact way as we've solved every equation we've ever done, ladies and gentlemen. We simplify first, we isolate, we keep balance. It all works out the same, no matter what you get in the end. So, we are going to first distribute to get rid of these parentheses. 6x plus 4 is equal to 2 times the quantity 3x plus 2. So 2 times 3x is 6x, and 2 times 2 is 4. So now we bring down to 6x plus 4, and that's equal to 6x plus 4. Wow, that's true. The same exact expression on both sides of the equal sign. Going further, combining like terms, if I move this 6x over and combine it with that 6x, I'm going to subtract 6x. And I'm left with 4 equals 4. Well, that's true. If I take it even further and I subtract 4 from both sides, to combine those, I get 0 equals 0. Well, that's true. I wanted to point out 0 equals 0 is infinite solutions. 0 equaling 0, some people think is no solution. That is not true. It is a true statement. 0 does equal 0. That is a true statement giving you infinite solutions. Ladies and gentlemen, pause your video. Join me again when you're done with example number 9. Welcome to example 9. 1/3 times the quantity 2b plus 9 is equal to 2/3 times b plus 9 halves. Wow, that looks crazy. But again, relax. You know how to do this. Just watch and listen. I know you guys got this. You got this. Have some confidence in yourself that you can watch, listen, and understand. Then you can write it down and understand more. You got this. So we're solving equations. What do we do first? We simplify. I see parentheses. I got to get rid of those. So 1/3 times 2b is 2/3 b. And 1/3 times 9, what's 1/3 of 9? Divide 9 by 3 and I get 3. Well, 2/3 times b again is 2/3 b. And 2/3 times 9 halves, well again, the 2's simplify out, 3 goes into 9 3 times. So 2/3 b plus 3 is equal to 2/3 b plus 3. That is true. I can technically be done and say infinite solutions. But we're going to prove it for more by saying, hey, if I move this 2/3 b and I combine these b terms by subtracting 2/3 b from both sides, I get 3 equals 3. And of course, I can subtract the 3's and I can get 0 equals 0. All gives us infinite solution. Ladies and gentlemen, pause the video, write it all down. Join us for example 10. Welcome to example 10, where we're going to write and solve some equations. It says number 10, the legs of the right triangle have the same length. What is the area of the triangle? Well, this only shows me two things that have any labels on them. So if you know anything about a right triangle, the two sides that form the right angle are the legs. They're technically called the legs. And we know they're the same length. It says so right here. So I know that 3x has to equal 2 1/2 minus 2x. I know it has to be. That's not going to give me the direct answer because the question says, what is the area of the triangle? The only way we're going to find the area of this triangle is to do what? Area equal base times height divided by 2. Some people know it as 1/2 the base times the height. I like the first one. Anyhow, doesn't matter which one you like, it works the same. So let's go back to our equation where we say the two legs are equal, so we made an equation where they're equal, so we have a variable on each side that we can solve and find out what our value is. So the first thing I'm going to do is combine like terms by moving this negative 2x over here and combining it with the 3x. They're on opposite sides, so I have to add them. I get 5x is equal to 2 1/2. I'm going to divide by 5 to isolate and keep balanced. So x is going to equal, what is it going to equal? Well, you take that and you're going to turn that 2 1/2 into 5 halves. Divided by 5 means changing it to multiplication by the reciprocal, and so that equals 1/2. X equals 1/2. Well, that doesn't tell me the side length. That only tells me what x is equal to. So I've got to take this 1/2 and I've got to plug it in here for x, and I've got to plug it in here for x. So in the first one, 3 times 1/2 is going to give me 1 1/2. Or I could stay with 3 halves. Okay? Well, the other one better be 3 halves. Let's see. What's 2 times 1/2? Well, that's 1. 2 1/2 minus 1 is 1 1/2. Or 3 halves. Outstanding. So now let's use that to find the area. I'm going to use the 3 halves. And I'm going to come up here and I'm going to go 3 halves times 3 halves. You guys know I like this formula here. I'm going to divide the whole thing by 2. Well, 3 halves times 3 halves is 9/4 divided by 2. And so I'm going to change that to multiplication by the reciprocal. And that gives me 9/8, which is 1 1/8. And it's area, so it's got to be some units squared. So the area of that triangle is 1 1/8 units squared. Ladies and gentlemen, pause the video, write it all down, and join me when you're done for example 11. Example 11 is a real-life application. It says a boat travels 3 hours downstream at r miles per hour. On the return trip, the boat travels 5 miles per hour slower and takes 4 hours. What is the distance the boat travels each way? That's kind of crazy. It is taking the assumption that there's something you know about distance. Because the question is, what distance? And I know that if I want to find distance of anything, I can take how fast it goes, the rate that it's traveling, multiplied by the amount of time it's traveling, and that will give me the distance. So distance is equal to rate times time. So, using the marking of the text, it travels for 3 hours downstream at r miles per hour. So when I plug this in, I'm going to go downstream. My distance is 3 hours times r miles per hour. So my distance is actually 3r. Okay. Now I'm going to mark my text for upstream. It says if I'm going, well, the return trip obviously is upstream, so over here I'm going to put up. And this time it's traveling 5 miles per hour slower, and it takes 4 hours. So my distance has to equal my rate, which is 5 miles per hour slower, so r minus 5, times the time, 4 hours. Okay. So what do I know about these two distances? Well, they're going to be the same. They're equal. The distance is equal. So now what I can do is I can say, since this d is equal to this d, I can say, instead of that, go 3r for that one. It has to equal the r minus 5 times 4 for that distance. Those distances are equal. Make sense? So now I have an equation with a variable on both sides that I can solve. We'll use the distributive property. 4r minus 20 is equal to 3r. When I combine like terms, I'm going to move this 4r to the other side by subtracting it from the 3r. I get negative r is equal to negative 20, and so I can't have negatives. I can't have a negative r. I've got to make it positive. Divide out by a negative 1, and I get r equals 20. That's r. R is 20. That doesn't answer our question. That tells me the rate is 20 miles per hour. So I need to take that 20 miles per hour and put it back into either one of the equations. So going downstream, I know my distance is 3 times 20, which is 60 miles. And if I want to do the other one, I can put 20 in here for that r, and I can say the distance is equal to 20 minus 5 times 4. Well, 20 minus 5 is 15 times 4. That's, again, 60 miles. So how far do we travel? 60 miles in each direction. Ladies and gentlemen, pause the video, write it all down, and then get to the quick write and write that down so you can finish. Oh, wait, my bad. I want you to write something down real fast. Sorry, this won't take long. So if we're solving equations and we come up to no solution or infinitely many, here's the things you recognize. 1, identical variables, opposite sides of the equation. Okay? Identical variables. The variable is eliminated. And most importantly, you end up with a false statement. Right? If we have infinitely many solutions, we have identical expressions on both sides of the equation. Again, the variable will be eliminated. But for infinitely many solutions, you end up with a true statement. Nice. Now get all that written down and then go copy down your quick writes and be done for the night. Our 2 quick writes, write them down. Ladies and gentlemen, absolute pleasure. Thank you for all your attitude and effort. I hope you are finding that the effort that you're putting in is showing dividends in how you are mastering your mathematics and changing your mindset on how you approach what you are doing. Thank you much. See you later.